Welcome to the video for 2.1. In this section we'll be talking about graphical and numerical solutions to systems of equations, the main topic in this chapter. The definition of a system of linear equations in two variables is given on page 31. And an example of something that we might encounter along these lines would be the system x plus y equals 90 and x minus y equals 50. So if I were interested in solving any one of these equations, I would just need to find an x and a y that satisfied that equation. For instance, our first equation, x might be 80 and y might be 10. Alternatively, x might be 89 and y might be 1. And we could also go past that. We could say x is 95 and y is negative 5. Any one of those ordered pairs will satisfy the first equation. Similarly, for the second equation, if we need x minus y to be 50, then x might be 50 and y might be 0. Or x might be 57 and y might be 7. Or maybe x is 45 and y is negative 5. Now these are just a couple of examples of solutions to the individual equations. There are infinitely many such solutions to each equation. But there is only one solution to the system, that is, the ordered pair if x is 70 and y is 20. So we can see that if x is 70 and y is 20, then they add up to 90. And 70 minus 20 would give us 50. So this is the solution to the system of equations. Generally speaking, in this chapter with our linear systems with two variables, our solution is going to be a single point. So the reason for that is that each of the equations in our system represents a line. And in 2D space on the Cartesian plane, a solution to a system is the point where the graphs of all of the equations in the system intersect. And lines can only intersect at one point, unless they're parallel, in which case some stranger stuff can happen. So we're going to be looking for the solution to this type of situation, this type of equation. Now, if I were interested in solving this by graphing, I would want to graph both equations in my calculator. So to do that, I'm going to need to convert these into something that I can plug in. So we need to put these in slope-intercept form. Our first equation, x plus y equals 90, I would like to isolate y. I can do that by moving x to the other side, subtracting x from both sides, and I get y equals negative x plus 90. So here we have a y-intercept at 90 and a slope of negative 1, that coefficient of x. Our second equation, if I have x minus y equals 50, I could still subtract x from both sides and get negative y equals negative x plus 50. Now I can't enter this as is because this says negative y. If I multiply both sides by a negative, then I could write it as y equals, now that negative is going to distribute on the right-hand side, making the x positive and the 50 negative. So these are the two slope-intercept forms of the original equations of this system. So I'll plug both of those into my calculator in the y equals screen. If I clear out anything that's already in there, I can type the first equation, negative x plus 90. Remember not to use minus, make sure you use negative. And our second equation on the second line, x minus 50. Now, if you still have the standard window, the negative 10 to 10 with ticks every 1 unit, and negative 10 to 10 ticks every 1 unit vertically, you're not going to be able to see either one of these lines. Our second line has a y-intercept at negative 50 and a slope of 1. So if you go to the table, and if you're currently on the auto populate for the x values, you see at 0, when x equals 0, your first equation gives you a point at 90, and your second equation gives you a point at negative 50. We knew that already. Those are the vertical intercepts. If you go down a little bit further, look out further to the right, 189 and 1 negative 49, neither one of those points is within our window. So these two lines are just a little bit too large for us to see right now. So my first approach would be maybe to try the fit zoom. So if you go to the zoom menu and scroll down to the fit option, then see what you can visualize from there. Well, now I can see the lines, but I can't see where they intersect. It appears to me as though they are going to intersect pretty far off to the right-hand side of my screen. They appear to be approaching each other in that direction. So from there, I'll go to the window, and I'll change my X max to something a little bit bigger. Let's say, right now I can see out to 10, maybe go out to 50. Okay, that's getting better. Not quite there yet, so maybe we'll go out to 100. Now, at the moment between negative 10 and 100, I've got 110 tick marks, so let me put a tick mark every 10 units. And I'll do the same thing in the y direction, because I've got a pretty big window there. Alright, so now we can see both of our lines much more clearly, and very carefully we can pick out the point where they intersect. And it appears to be at about 70-20, just like we thought. Now, to verify that, what you'll need to do is calculate that intersection point. So if you hit second to get the shift option ready, and then hit trace, that'll open up the calculate menu. So the object, or the point that we're interested in, is the intersection of these two lines. We want to make sure they cross each other at 70-20. So if I go to intersect and hit enter, now what the intersect option now requires, it wants to know which two curves you're interested in, and it wants you to then approximate where you think they intersect. Now we only have two curves to worry about, but it's still going to ask. So it's going to say, is this the first curve? And you see your little cursor blinking on the first line that we graphed. If you hit enter, then it'll ask you about the second curve, and you can see here we're on the second line that we graphed. And now it asks us to guess. Now, your guess doesn't need to be very good with this situation. We'll see other situations where you need to be a little more careful about this. But just kind of scooch over to approximately where you see the intersection. And hit enter again, and you'll see our solution point, x equals 70, y equals 20. So that is how you calculate the solution to a system of linear equations in two variables. We will be doing much more with that. You can also solve these by using the table feature. So another possibility, as we said, you could use the table. You might find this possibility, this option, a little bit tricky. So this really only works in very special, nice systems. For instance, if we had the system y equals negative 3x plus 5, y equals 4x minus 9. So both of these equations we would like to solve simultaneously. So I will plug them both into my calculator. On the first line we'll do y equals negative 3x plus 5, and we don't have to do any work because both equations are already in slope-intercept form. On our second line, 4x minus 9. Now if I graph this and go back to a standard zoom, so zoom 6, We can see that there is a nice intersection point, and just guessing, it looks like it's around 2, -1 maybe. Now you can check this if you go to the table, and if, again, you are on the auto setting for the table, you'll see when x equals 0, the first equation is 5, the second equation is -9. That makes sense because those are our vertical intercepts. If x is 0, we would just get the constant. If x is 1, we would get 2 and -5 respectively for our y value. But if x is 2, we get -1 from the first equation and from the second equation. So both lines pass through the point 2, -1. In other words, they intersect at that point. So that's how you would use the table to solve these types of equations. You'll need to, again, plug in whatever the equations are. You may have to manipulate them to put them in a form the calculator can understand. And then you kind of just look around on the table and see where would that intersection point be? Where do your y values match? So that's all I'll say about the numerical approach, that is, using the table of values to solve these types of equations. Now on the next page of the notes, you'll see several definitions for some business-related terminology. You'll see the definition for revenue, for cost, for the break-even point, for the profit, and those definitions are all dependent on how many items are being produced. So in our next example, we'll look at a small business that Sarah has, making and selling video game-themed pendants on some online marketplace. The materials for each pendant cost her $6 a piece, and initially she invests $1,200 for all of the equipment that she uses to produce her jewelry, machinery and clasps and that type of thing. She also, we are told, sells each pendant for $42. So, just a little bit of reference, in business parlance, revenue describes the amount of money coming in from a transaction, or from some number of transactions. So this is purely, you sell an item, how much money does that make you? You sell 2 items, how much money does that make you? That does not factor in how much it might have cost you to acquire those items in the first place, to have them to sell. So the revenue is simply going to be the number of items times how much she can sell them for. So we might say that the revenue function is a function of the number of pendants that she sells, and she makes $42 per pendant, so that would be 42x. If she sells 1 pendant, she makes $42. If she sells 2, she would make 42 times 2, or 84. Now the cost function is not quite as simple. The cost depends both on how much it costs her to start her business, which we would call an initial or a fixed cost, and on top of that she has to pay for the materials for whatever she's producing. So our cost function, we are told she pays $1,200 to get her business off the ground, and on top of that, if she produces X pendants, we know that each one costs $6. So that would be our cost function, $1,200 plus 6x, or if you prefer to write it in descending terms, you could write 6x plus 1,200. Now the break-even point is defined to be the x value, the number of units, where the cost and the revenue are equal, or sorry, the cost function and the revenue function are equal to each other. So what we would do is set our cost function, 6x plus 1,200, equal to our revenue function, 42x. And then just solve that for x. So one way we might go about this would be to subtract 6x from both sides. This leaves us with 1200 equal to 36x. And if we divide both sides by 36, we see that x equals 33.33 bar. So, in this case, we end up with a break-even point that isn't technically possible, right? She can't produce and sell 33 1/3 pendants. So we could round that down to 32, in which case her cost might exceed her revenue. Or we could round it down to 33, in which case her cost might be larger than her revenue. Or we could round it up to 34, in which case her revenue might now exceed her cost. So if we do the former, we would like to know what are her revenue and cost at the break-even point. So, her revenue at 33 is going to be 42 times 33. Simple as that. I calculate this to be 1,386. On the other hand, we would like to know what is the cost of producing these 33 items. So the cost to produce 33 items would be 6 times 33 plus 1,200, which I calculate to be 1,398. Now, finally, we would like to talk about the profit side of things. So the profit function is simply the revenue minus the cost. So how much money are you able to bring in minus the cost of doing business. So we have our revenue function, that was 42x, and we know that our cost function was 6x plus 1,200. So, if we subtract the cost from the revenue, make sure you don't forget about the distribution. We're subtracting 6x, and we're subtracting 1,200. So that leaves us with 36x minus 1,200. And that is our profit function, and we can use that for part F. If we would like to know what is her profit if she sells 20 pendants, well, we can plug 20 into the profit function. That would be 36 times 20 minus 1,200, which I calculate to be negative 480. Now, what could that mean, having a negative profit? Well, if we think about her situation, she's not producing very many pendants at this point. She's only producing 20. So she's working to pay off that initial investment, the $1,200. And on the whole, she only gets $36 per pendant, right? She has to spend $6 to make them, and then she charges $40 to the consumer. So she hasn't quite caught up with the $1,200 debt that she currently owes. Let's see if producing 100 pendants, if she keeps going a little bit, if things look better for her. So the profit from selling 100 pendants, that would be 36 times 100 minus 1,200. I calculate that to be $2,400. So at the beginning, she's got a bit of a hole to dig herself out of, but if she just sells 100 pendants, she will finally be making a profit. She'll make a profit of $2,400 that she walks away with. Now our final question, and this is where it really comes in handy to have a profit function to work with, if we want to know how many pendants she needs to sell in order to make a certain profit, we can say, okay, we want the profit to be equal to that value. So how do we get the profit to be equal to 500? Well, we can set the function 36x minus 1,200 equal to 500. And from there, all we need to do is solve for x. See, What we were asking is how many pendants, and since x represents the number of pendants, we're on the right track. So if I add 1200, we'll see that 36x equals 1700. And if I divide both sides by 36, I get x alone. And again, our division here results in a slightly strange number, 47.22, and so on. Now again, since we're talking about actual tangible goods, it doesn't make sense for us to stick with this number, 47.22 pendants. Well, somebody's getting 0.22 pendants, and they're probably not going to be very happy about it. In fact, she probably wouldn't sell that to begin with. So what we would do instead, since our interest here is to make a profit of $500, if we make more than that, just slightly more than that, then we will at least have the 500 we were interested in. So if I round that up to 48, that should do the trick. Now just to make sure, I'll plug 48 units back into the profit function. So profit from selling 48 pendants. We're going to make sure this is more than 500. So that would be 36 times 48 minus 1200. And that gives us a profit of $528. Now if we sold one fewer pendant, we wouldn't quite get there. We would have 36 less dollars and be below 500. So this is the first X value, the first number of pendants that we come to, where our profit is greater than 500. And that is what we are going to need in order to satisfy that question. So that is about all that I wanted to discuss, anything new out of this section. Make sure you get started on those homework problems as soon as possible. There are a few word problems in there, but nothing that we haven't worked with before. So if you struggle with those, let me know. Bring your questions to class and we will go over them.